Somebody brave.
It's basically an early start for summer transfer students. We're coming a little early and we get a little bit of the university experience before entry.
And freshmen too.
Okay, that's good. We're about to finish and then you
All
can.
the same line.
So you're a transfer student.
And I thought it would be a good idea, because you get an extra class in, as well as the class that's probably only offered in summer, the University 83 studies, which will give you, an idea of where resources are, how to network, and how to get help, and how to express yourself.
Okay, great. And who yelled out in freshmen?
Oh, that was me.
Okay, so you're a freshman. So how many freshmen have we got here? Okay. Oh, great. Most of you are freshmen then. Okay. So we'll just lay some ground rules and then we'll reiterate these. But at the end, I'm not in any hurry. I will eventually die of hunger, but until I die of hunger, you've got me. So, if you have questions, like, what's your name? Josh. Josh asked me, how do you get into engineering? And I said, you work your ass off. That's a very simple answer, but there's actually more complicated things. But
So Josh is an engineering major. Are there other engineering majors, either freshman or transfer? So there are some freshman engineers.
good. Chemistry majors? Woohoo! You're the good guys. Biology. So I'm a closet biologist too, okay? So,
So
yeah.
that covers more than half the room.
That's right, we're good, we're good.
So we all drink water.
Well, you're supposed to drink water.
Point.
You
How
just,
many people drink water?
you're just not supposed to drink it out of a plastic bottle. But I got this they gave it to me, so I have to drink it. But we're actually starting a movement in the near future, to try to have steel bottles for all the incoming freshmen, and then have places around the university where you can actually fill them up. Because one of the things I do is the plastic ocean, which I've done 3 cruises. I've done 2 in the North Atlantic and 1 in the Pacific, from Honolulu to Long Beach, on a 50-foot catamaran collecting plastic out at sea.
And we gave him this bottle so that would come up.
Right. And in 1992, I did a ABC's 2020, which is a TV show, I don't know if you're David Stossel, on bottled water, where we analyzed 35 different bottled waters. And it was fun.
And what were the
Well, we found out that chemically there's no difference between that and Miami or New York City water. I was in Miami at the time.
My sister is an attorney for a water district, and she says the water out of the tap is safer than the water
It is.
in plastic bottles.
It is, because of the phthalates and the stuff that are in the plastic.
But is it also because it's not regulated as much?
That's what she says.
That's a very, very good point. The water coming out of your tap is regulated by EPA. This is regulated by FDA, and I'm going to almost guarantee you they've never done a test on this.
What about the fluoride in tap water?
The fluoride's a different question. So the fluoride is still an open issue. I happen to see, I was raised where we didn't have fluoride, and I have a lot of dental cavities, and maybe that's just my teeth. But I know that my boys who had fluoride, they actually had a lot less dental caries. So I think fluoride, I'm still actually pro-fluoride. I think it's good for your teeth, as long as we don't get too much. And here we regulate it very, very carefully. We don't have fluoride in the groundwater here, so it's not a big problem. But those are good. Oh, we're going to have a great time. You guys are going to get to laugh at me, too. Woo! Just be careful of the tripod there, you guys, coming down.
So did anyone here actually do a little research on Professor Cooper? Look at what he
That's
studies?
scary.
No need to be
You
scared.
gotta go.
They can do it right.
We'll do it less.
I think it's incredible though, right?
When they So the architect of this building is actually the most famous architect in the world, and his name is Frank Gehry. And he's famous for large museums all over the world. And he has clients who want to make a place, make a name for themselves through their architecture. That's why people hire him. And UCI did that. Sort of at we're talking ancient history now, before you were born, in the mid-'80s, UCI hired him to do this building, and it was used as the icon for the campus on publicity materials for a really long time. But that's enough of that. We are here to hear from Professor Bill Cooper. And one of the things that we want to do in this Inside UCI series is kind of show you who professors are and where they come from and how their research interests develop. So we're here to hear about water from the director of the Urban Water Research Center. Was he always interested in water? That's what I wanted to know. So here's what I have to tell you, that Dr. Cooper received a BS in chemistry from Allegheny College in 1969. His thesis was on the origin of oil. And from there, so that's like late 60s, a couple of years later, he was at Penn State studying the origin of coal. And then did service in the Army, and as a civilian, he ran a water reuse program. And then went to Florida and became the director of the Drinking Water Research Center and completed his PhD at the University of Miami in 1987, about the time this building was built, actually. And then he came here actually just 4 years ago, and since he's actually mysteriously in the room at this moment, I'm going to let him continue the story from there. If you will, please, Professor Cooper.
So I'll get to the story about my clothes at the end, but I gave a talk several weeks ago to a bunch of UC Leeds students, and it's interesting to see, looking back, you realize that the road forward that you're about to embark on is never straight. It takes all sorts of twists and turns. The first obstacle that was thrown up in my life was I flunked out of college. After my sophomore year, they said, you're out of here. So I worked for a year at Eastman Kodak Company, went to night school, went back to school, actually ended up staying an extra year because I played 4 years of collegiate soccer, so I wasn't eligible when I went back, so I wanted to play soccer, so I actually stayed an extra half year. But I ended up then doing something that I always dreamt of being an oceanographer. I had read Jacques Cousteau's story on the invention of the scuba. And so anyway, at Allegheny College, a small liberal arts school, and then we had 1,500 students there, we were required to do an independent research project for our senior year. And I said, I want to do one in marine chemistry, something in oceanography, because here I was in the middle of Pennsylvania, they were about as far away from the ocean as you could get. Well, I did a crazy thing, and this is something that you should remember. I talked to one of my professors, and I said, I want to do a project in marine chemistry. And I said, but nobody here does that. So I thought maybe what I would do was to write some letters to universities to see what might be an appropriate project to do marine chemistry. And I wrote to 4 universities, and I don't remember exactly who they were, but I do know that I got a wonderful letter back from the University of Hawaii. And this guy said, you should study lipids and sediments. It was a 2-page letter. He said the bottom line was you should study lipids and sediments. And I thought to myself, what the hell's a lipid? I had no idea what a lipid was. So, and you now know lipids because we talk about lipids and fats and stuff like that with our food. But I didn't know what a lipid was. So, and coincidentally, the next week, an American Scientist article came out about lipids and sediments by a Max Bloomer at Woods Hole. I called them up. I either wrote them or called them up. I don't know. We didn't have email at that time. Now, mind you, this is in the 60s. In fact, I was carrying a slide rule. I didn't even have a calculator. We used to. You knew all the geeks on campus because we all wore our slide rules on our hip. You know, the old John Wayne whip out your slide rule trick. So at any rate, I wrote him a letter and I said, "Can I come up for my spring break and see what a lipid and sediments are?" And he put me up at visiting quarters for scientists. Woods Hole is second only to Scripps Institute of Oceanography in the United States for oceanographic work. Well, to make a long story short, I worked for him for the summer. I published my first paper that fall in a peer-reviewed journal, and it happened to be in Science, which is one of the most difficult papers to ever, journals to actually publish in. So I published my first paper ever in Science after I flunked out of college. I then went back over Christmas and did my entire independent project on my second paper on the origin of oil and published that in Deep Sea Research. But I was a senior author on that. So that's just one example of what you want to do is you want to be prepared for life. And the more you can prepare yourself for life, the more you talk to faculty, the more you talk to people, the better you're going to be prepared for life. Because you just never know. Something might happen. I mean, who would have ever thought that a dumb cluck like me would actually end up publishing 2 papers before I graduated and end up even furthermore being a full professor at the University of California, Irvine, which is quite an honor. But, so that's a little background on me. It's a sordid background, but the purpose for telling you that is to make you comfortable, and even though I'm dressed kind of funny here, I do have pants under this in case they fall down. And I didn't kill the lion this morning, so I'm not a Maasai warrior. But if you have questions at the end, I'll be happy to take them, okay? I am considered the water boy on campus. I direct the Urban Water Research Center. My entire life is built around water. I started doing water actually when I got drafted into the Army. That'll make it a little easier to see, maybe. I started doing water when I was drafted into the Army, although my first 2 papers were in oceanography. And I've been doing water ever since. So the easiest thing to remember is that my email address is wcooper@uci.edu. And when you come here, my office is just down here in Engineering Tower on the 3rd floor. And I'd be happy to talk to any of you if you can catch me on campus. And if you see me on campus, grab me, because then it's the easiest way to find me. So if I'm not in my office, I'm usually drinking coffee over at the Phoenix Grill and having lunch. Okay, water, in my estimation, is going to be one of the most critical issues that faces you as students and society of the 21st century. There is nothing we do on a day-to-day basis that doesn't, in one way or another, affect or be affected by water. And it's interesting that here in Southern California, where we're living in a desert, you've noticed that Aldrich Park out here is green. That's all treated sewage. That's all wastewater that's been reused and reclaimed right across San Diego Creek at the Michelson Irvine Ranch Water District's water plant. And we'll talk about this, and we can talk about that a lot more. But water, as far as I'm concerned, is one of the most critical issues that faces us in the 21st century. And what do I mean by the water sector? From an industrial point of view, we have ultra-pure water. You may not know it, but the most pure water that we can produce is used for making chips for your computers. The electronics industry requires extremely high purity water. No ions, no organic matter, and it costs them a fortune just to take that water. So that's at the top. Drinking water, we were talking about, a couple of us beforehand. I actually never drink out of plastic bottles, but today they were kind enough to give me some water to drink, so I'm going to drink out of plastic bottles. But I'm doing some work in the plastic ocean, and when you see these things floating 3,000 miles out in the middle of the Pacific, you think, my God, what's going on? It's an interesting story. That's a whole other story. Domestic and industrial wastewater. I've been involved in wastewater in a whole bunch for many, many, many years, and I've started a little. I'm launching a new website this year, and one of the aspects comes from a question that my daughter asked me when she was in 5th grade. She says, "Daddy, where does poop go when you flush the toilet?" So that's a good question. And so what we did is we spent a half a day at the wastewater treatment plant with a video and a camera. Happened to be a high school teacher here that asked the same question, and she got routed to me, and we took her down with us and talked about how do you treat poop and then how do you reuse the water. And so wastewater is near and dear to my heart. Water reuse, as Molly said, I actually ran the Water's Army Reuse Program and funded the first international conference looking at the reuse and recycle of wastewater. And that was in 1979 in Washington, D.C. And today, the world's largest indirect potable water reuse plant is 5 miles north of here. In fact, I was there yesterday. It's in the Orange County Water District, where they take 70 million gallons of wastewater every day and they purify it, and then they re-inject it into the groundwater at your drinking water. That water is more pure. In fact, it's a shame we can't just drink it straight, because it's much more pure than the groundwater. But because of public health aspects, they don't want us to do that. So then we also have some of the dark side of water treatment. We call it sludge. And I'm working on sludge. We're doing some work with reverse osmosis and membrane processes, contaminated groundwater, and much, much, much more is the water sector. So there's many, many aspects of water, whether you're studying, if you're a good guy in studying chemistry or a bad guy in studying engineering or a neutral person like a biology major, everybody needs water. And so I probably didn't pick out enough majors here, but we'll get to that later. So water, when I think of water, when I think you have all heard of climate change, you've all heard of sustainability. When I think of sustainability, I think in terms of water. And we're going to get into this. But basically, I think water reuse, as far as water is concerned and sustainability is concerned, is like the central theme. We have to learn how to reuse our waste to minimize our dependence on other water. Since climate change has become important, it's a game changer. We now are looking at, and you will be exposed to these ideas of climate change. No matter what major you're going to be in, that's going to impact you one way or the other. And we now have to consider, when we're thinking about water and water treatment, we have to look at climate change. And CO2 is the biggest single molecule for climate change. And now, so we have a lot of work going on in the Civil and Environmental Engineering Department. Diego Rosso is doing both carbon footprints and water footprints of water processes. Some of the considerations that I think are being, and this is maybe a good time to just say, there's any major in the university, you can come back and intersect with water. Economics, as an example. I heard an idiot, probably a politician, talking about, oh, this is too expensive. I don't like politicians. And I say, yeah, but what do you mean by expensive? When we think about the fact that we as a society don't have the guts to put the cost of a human life, we don't know how to evaluate a human life, right? Now my life is much more valuable than you guys, because I'm a professor and you have to listen to me, you see. But the point is, I'm just teasing. Don't take me too seriously on this, okay? But what I do want you to take away from this is that think about climate change. Think about sea level rise. At the end of this century, and most of you will see the end of this century, I won't, we're going to have this much more water, a meter of water increase in the sea. I just happened to have dinner down in Newport Beach the other day. The place I had dinner is going to be underwater at the end of the century. We are going to lose 20 nations in the world. There's 193 nations. 20 of them will be underwater with a meter of sea level rise. So when we say we can't even evaluate the cost of one human life, what about a country? Now, I know if your dads are rich, they may have money down in the Cayman Islands. Take it out in 2050 because they're going to go underwater. So economic models are going to be critical. You are going to have to face some very, very, very difficult and contentious issues, not the least of which is the input to economic models. Biosolids, this sludge, is going to become very valuable. That's the bug bodies left from when we treat wastewater. It's going to have phosphate in it. during your lifetime, phosphate as a fertilizer is going to be no longer available because all of the known phosphate reserves in the world are going to run out. Biosolids, sludge is going to be extremely important. The biggest enemy in agriculture is salt. I don't know how many of you like to go swimming in the ocean. I certainly do, and I'm a scuba diver. Well, I'm also got my PhD in oceanography, so I've spent a year actually sailing around the seas doing research. Salt, when you're out there playing in it, is fun, but it's a horrible thing to have to drink. And agriculture, it actually ruins many agricultural crops. One of the big areas, for example, is in plant biology, is trying to develop plants that will grow in higher saline environments, so we have sustainable food sources. I'm not going to go into the rest of these. Well, my big research is actually on pharmaceuticals. In fact, I just got a $360,000 research grant a couple of weeks ago to look at the treatment and the fate of pharmaceuticals in water. So we're all peeing out pharmaceuticals and endocrine disruptors. We're the problem. And I'm more of a problem than you are because I have to take 2 heart medicines, one for my high blood pressure and one for my my cholesterol. And then I take 2 more medicines because of my glaucoma. So I pee out 4 different medicines every day because I only use about 50% of them. And then we pee them out. They go through the wastewater treatment plant, they get into natural water, come back in as a drinking water plant, and we don't get rid of them there either. So we don't know if these pharmaceuticals are going to have an adverse health impact on us. We know that they have health implications, otherwise we wouldn't be taking them. They actually do something to our bodies. But what the real problems are as far as human health is concerned, we do not know. We do know that we've observed changes in ecosystems as a result of these endocrine disruptors and pharmaceuticals. So that's a really interesting area. Engineered nanoparticles. Nanoparticles are such a revolution. They're doing all sorts of great things, but they don't behave like other particles in water and wastewater, and we don't know how to treat them. And we don't know what the potential health effects of those are either. So there's a whole bunch of other stuff. But you can see that, whoops.
There is no greater issue confronting the world than the water scarcity and quality crisis.
We all should just look at that. Just think about this as your source of drinking water.
There is no greater issue confronting the world than the water scarcity and quality crisis.
In the world today, well, I'm getting one ahead of myself. So the bottom line is we are not living sustainably with respect to our water resources. And I would argue that if we don't live sustainably within water, we are not going to be able to live sustainably as a biological organism on this planet. The planet is going to survive. The question that's going to face your generation is, are we as Homo sapiens going to survive? And that's not a trivial question. And that's not a question that you should ask lightly. Because there's not one person in this room that can't help solve the problem of sustainability of people on the earth. I contend that the biggest enemy of water is uncontrolled population growth. This world was never designed to carry 6.7 billion people, no less than 9 billion that's going to be here in 2050. And 2050 is right around the corner for you guys, I guarantee you. I don't think I'll see 2050. Well, God, I hope not. I'd be pretty old by then. But you never know. Better living through chemistry, right? But the biggest unknown in all of the water field is climate change. Climate change, in my mind, there is no doubt about the fact, and you may not agree with me, and that's perfectly acceptable. In my mind, there's no doubt that we, mankind, has resulted, it's our fault that we have climate change. There are all sorts of oscillations, and we've studied those oscillations over the last 500 to 600,000 years using ice cores from both Antarctica and the Arctic. But there's no doubt in my mind that climate change is the result of us. And the question that keeps me awake at night is, what kind of a world am I going to leave to my grandkids? I got a 10-year-old, 11-year-old, and a 9-year-old. And And they're going to say, Grandpa, if you don't do something, we're going to look back at you and say, what on earth were you thinking? So what's the worst word? I'm going to just, a little philosophy here. What's the worst word in the English language? Or in any language? Greed. Greed is at the bottom of all the nonsense that we have to face today. Look at the BP oil spill. It was greed. Greed, and then a little bit more greed that led to the disaster in the Gulf. And it doesn't stop with the petroleum companies either. It's rampant within the government as well. So on this earth of 6.7 billion people, 1 billion people don't have access to water. When you go to Africa, and you might imagine that I've been in Africa recently, when you go to Africa and you see these young women, and it's almost always young women, that are carrying jugs of water on their heads for 2, 3, 4, 5, 6 kilometers at 14 years old when their bodies haven't even fully matured. You can imagine the impact on that woman once she grows up. 2.5 billion people don't have access to sanitation. We are so spoiled in this country. It is so difficult to imagine. When I was over in a little Maasai village, and I'll show you some of it a little bit later, I went into a little hut. No one running water. Of course, no sanitary facilities. But the people were beautiful and they were very, very happy. But just think what they would have if they had a little bit of water. The thing that drove me nuts about this, well, the government before and maybe now too, but the two Iraq months, the amount of money that we spent in Iraq in 2 months would have solved 50% of the world's water problems. 2 months. It's unbelievable. It drives me crazy. So can you believe in this day and age, watch this really carefully.
Worldwide, a child dies every 15 seconds from diarrhea.
It's a baby.
These quiet, preventable deaths hardly receive any attention.
So I want to play that again.
Worldwide, a child dies every 15 seconds from diarrhea. These quiet, preventable deaths hardly receive any attention.
5,760 children die every day as a result of diarrhea. Can you believe that? A simple, treatable disease that would cost almost nothing. 6,000 kids die a day. And you don't even have to go to some of the developing countries. We have our own developing countries in Arizona, in our native Indian reservations. Horrible, horrible situations. I think that if nothing else, if as you go through the next 4 or 5, or if in my case 6 years to get out of school, thinking, and every day you just think about, remember that crazy guy that was running around in that red robe and he talked about water. Just think about water. Think about how easily and accessible it is. And if you have an interest in helping like developing countries, we have a phenomenal Engineers Without Borders. They're leaving on Friday of this week, the student group, to go to Kenya. They're going to go to a city north of Mount Kenya, and they're going to be working with a school to give a little school water for the students. A little act of kindness, costs almost nothing, but it makes a difference. And that's really cool. Making a difference. When we talk about water and we talk about a population, by 2050, the amount of food that we're going to have to produce is going to be 70% more than we produce today. The problem is, in the United States, how many of you have flown over the United States? Maybe other places. I've just flown from like here to the East Coast. And if you've ever sat by a window and looked out in the middle of the United States, just miles, in fact, hours after hours of nothing but lush fields that are raising crops. All of that agriculture is based on cheap oil. Okay? Cheap oil is the reason we've got climate change. So we have a problem. Agriculture as we know it is going to face radical changes in the 21st century when we run out of oil. And God forbid we don't start using coal for oil, because that coal will kill us as far as climate change is concerned. There's plenty of coal to power the world for another 200 or 300 years. If we burn all that coal, you guys won't have to worry about you could be wearing clothes like this anywhere, because it will be so warm. That's probably going to take a couple hundred years, but so you probably won't see that. But the point is that water is going to be right at the intersection of food and also oil. So we've got these nexuses, we've got these intersections of competing needs. We need food and we need water. We need food, we need oil, or something. We need to change the way we do business. In the United States, it's really interesting, because water is one of the, if not the most essential thing of life. I remember taking my economics course, this is going way back, in 1959 as a freshman in high school. And the first day we learned that water, food, and shelter were the three essentials of life. Interestingly enough, they hadn't identified air, oxygen, as being an essential of life, which we know now it is, of course. But so we got to add that. But I think water, if you don't have water in any shape, you'll die within about 5 days. So without water, you're dead meat. The regulatory framework that assures us of clean water was built basically in the 1970s, when we had about 210 million people in the United States. The most recent census has put us, I think, a little bit over 307 million. So we've got 50% more of a population today than we did when all of the environmental regulations were formulated. And it's about time we start looking at some of those. The world population as of April 21 was 6,774,701,760, plus or minus 3. Do we have a problem? I think we do. I think we've got a major problem, and it starts with you. Well, actually, I like to even take it a step lower. I do a lot of work with the K through 12 students and getting them excited about water. And I'll show you a little bit of stuff we're doing. But we've got to start to do some drastic rethinking about how we deal with water. Climate change. As I mentioned, population is the biggest enemy of water. Climate change is the biggest unknown when we're working with water. Pat Mulroy, a friend of mine, who runs the water and wastewater for all of Las Vegas, when she was asked the question, what keeps me up at night? And her answer was very clear: climate change. And I'll show you why she's worried about that. This is an interesting fact. This one right here in the bottom. If you think about the Earth, it took us 200 to 300 million years, maybe even, well, if you think about plant life, bigger plant life only started in the Devonian or so. That's 500 million years ago. So there's no coal, all comes from plants. So it might be 400 million years. But basically, in the last 200 to 400 million years, we have accumulated the oil and the coal reserves that we are now burning up in 200 to 300 years. Is it no wonder that we've got climate change? We're burning things 1,000,000 times faster than Mother Nature can accumulate them back in the ground. So that's an issue. And that's something that people seem to forget. That these people that say, oh no, it's not us. We're not the problem. I won't even tell you what I tell them, because it's polite company here. But anyway. Interestingly enough, you're living in an area in which we import 60% of our water. 30% comes from the northern portion around San Francisco. Inside is called the Bay Delta area. And 30% of it comes from the Colorado River. Now, in order to get from the Colorado River to here, you have to go over the San Andreas Fault. That's a big slip fault that's going to allow California to be near Alaska in another couple hundred million years. But that slip fault, we had 400 little earthquakes around here last year on the San Andreas Fault. If we have a major one in the southern part of that fault, it's going to rupture the line that brings 30% of your drinking water to Southern California. If we have an earthquake, and it's not if in the Bay Delta area, it's when we have an earthquake in the Bay Delta area, we're going to lose another 30% of the water that comes down here to Southern California. So we're in a unique system. I mean, we love Southern California. Look at the day-to-day. We're in a desert. We never rains. In fact, I go home to the East Coast. I forget to take my umbrella because it rains there. But it's wonderful. But we have to realize that we have to respect our water. And we don't know what's going to happen with climate change. All of the climate models, the global GSM, the global whatever they are, the global change models, all predict that the Southwest is going to get drier. And that's pretty scary. If you think about Lake Mead, if you think about the Hoover Dam, I'll show you a picture in a second. Lake Mead is the largest reservoir in the United States. That's where we get 30% of our water, folks. That's where Las Vegas gets all of its water. Located in the Colorado River, about 30 miles southeast of Las Vegas. It's impressive. If you ever do want to take a little hike over to Las Vegas or to Hoover Dam, it's impressive. To be on that dam and look down and you think that we built that dam. And it's got a lake behind it. It's 112 or 112 miles, 180 kilometers. It holds 28.5 million acre feet. An acre foot, that's the amount of water that covers an acre of land, is about 325,000 gallons. So if you multiply 28.5 million times 325 or 335,000 gallons, that's how many gallons of water in there. 35 cubic kilometers, so a kilometer by a kilometer by a kilometer, is how much water is in the Hoover Dam. You talk about a case of ring around the collar. This guy's got a case of ring around the collar. This is Lake Mead. This is in 2007. Lake Mead's elevation was 15 feet lower than the year before. And at that point, it was 118 feet below its maximum. I've seen this. I've flown over Lake Mead in an airplane at 37,000 feet, and you can see the ring around the collar, that white where the water used to be. This year, I think maybe I got some data. This year, it's even lower, so it's only at 46% of capacity. So by lowering us 118 feet, they've lost over 50% of the storage capacity of that lake. Lake Mead in October of 1998, the way they do this is feet above sea level. It was 1,600 feet above sea level. In June of 2010, it was 1,089 feet, or 127 feet below maximum. It's the lowest level in 40 years. And my friend Pat Mulroy, if it keeps going like this, if she doesn't complete her $2 billion pipeline into the bottom of Lake Mead, she won't have any water to feed the people in Las Vegas. Another 20 or so feet, I think it's 20 feet, and then we'll get no electricity from the Hoover Dam. We use 30% of the electricity that we use in southern California is from Hoover Dam. And it's possible that within the next couple of years, it's going to be below 1072. I think 1072 is the number. I wouldn't quote me on that one. But the bottom line is, climate change is taking its toll. And Baby Cakes, that toll is going to be right here. We're going to be in a big, deep problem. GCMs, global climate models. So we're in a 10-year drought. Last year, because of El Nino, we actually had a little extra rain here. We had 2 inches of extra rain. Most of that just ran down the stormwater drains and out to the ocean. But it turns out that they didn't have much excess rain in the Colorado either. So they're in a 10-year drought. And the question that is driving Pat crazy is Pat Mulroy, the general manager of the Southern Nevada Water Authority. is this a drought or is this actually the new norm? And the interesting thing is that that Colorado River feeds California, Arizona, Nevada, Colorado, Utah, 7 states, New Mexico. And when they sat down at the table and allocated how much water each state would receive, it happened to be, from a historical point of view, at a high water flow. We're now at low water flows, and that means that we have oversubscribed the Colorado River. That means that there's more water that people can legally take than exists in the river. And that means that there's going to be wars in the near future. So can you imagine in 2076, you guys will be here. You can see if I got this right. 7 states in the southeast U.S. are at war over water. And Mexico is threatening to invade. Not even just involved, they're going to invade us. We've already taken all the water out of the Colorado River. We've just screwed Mexico. We've just taken it out of there. They don't even have any Colorado River that flows into Mexico. We steal all the water from them. Talk about international politics. That's how nice we are to our neighbors. Okay, let's look on to a brighter thing, sea level rise. So the good news is when I came out here, I bought down in Aliso Viejo at 700 feet. So I'm way above. When all the ice melts, I'll be able to ride my boat here to work. Of course, Irvine will be on the water, but we don't worry about the little details. This looks at the level increase in sea level from 1960 here to 2003. Actually, I brought my pointer. They gave me this. Of course, I always leave it in my office. So you can see that even though it's not much, this is the change in the mean sea level in millimeters. There's a steady increase over the last 10, 20, 30, 40 years, right? Well, if we look at the average for the last 40 years, this is what the line that you get. Look at what's happened if you change and look at the average for the last 10 years. It's doubled in rate. Now these are numbers, of course there's a lot of variability in these little dots here, because it's hard to determine. But these are as a result of measurements all over the world. So you can see that if we even stay here, it's likely that it will even increase in time. So 1 meter, we lose approximately 20 nations. If Greenland melts, the world's oceans are going to rise 7 meters. 7 meters is how much ice is on Greenland. My son went as an undergraduate, he did what was known as an REU, Research Experience for Undergrads. Write that down. That's something you all want to do. Research Experience for Undergrads. He went to Greenland and he helped bore holes in the Greenland ice sheet. It's 10,000 feet deep. 10,000 feet of ice in Greenland. When that melts, and it's not going to happen overnight, but if it were to slip off Greenland, the world's oceans would go up 7 meters. That would mean we'd be in trouble. If Antarctica melts, the world's oceans are going to rise 55 meters. That's how much snow and ice. Now, if the Arctic melts, it doesn't have any effect on sea level because the Arctic ice is floating on the water. And if you take I got stumped on this one time. So this is a take-home experiment. Take a glass of water and put some ice cubes in it, and measure and put a little dot on there, and then let the ice melt, and you'll find that the water level stays exactly the same. Okay? Because it just displaces its weight in water. So if the Arctic melts, it's not going to have any effect on climate change. It might screw up the polar bears, but do we care about those cute little white bears? No. The interesting thing about these numbers is that the recent indications over in the Earth System Science Department, over in Physical Sciences, by the way, we have one of the top groups in climate change collectively of any university in the nation. And it's right here at the Earth System Science. They're doing some work on this, and it looks like the estimates that the IPCC, that's the Intergovernmental Panel on Climate Change, has underestimated the rate at which the Antarctic and the Arctic are melting. So it may be that we're going to have this meter sea level rise much faster than they were predicting by the end of the century. Okay. So economic models, I've already ranted and raved about those. But the point is, if you are in economics or interested, I think economics is going to play a huge role in the 21st century. So how would one start to address these issues? When I was in growing up and going to school and actually got drafted out of my PhD work, so I was in the Army at the time, working with a guy, a bit of advice that he gave me is something I think that's well worth repeating. And that is that when you go through your academic career and you start getting out into work, try to become an expert in one area. Okay? Because once you're an expert in one area and you've established your expertise in an area, you can then actually do other things. I've actually, through my career, become an expert in chlorine analysis for drinking water. I dabbled in biogenic sulfur for a little while. I'm now considered an expert in advanced oxidation processes. But all the time I get into these new areas and you find that you go back to some of the roots. I just published a paper in 2007 that I wrote the first draft of in 1984. It took me 23 years to publish the bloody thing. Because I wrote it and didn't really know what the story was, but then the story came along in 2007 and we published it. So, there's a lot of interrelated stuff, but if you can become an expert in one area, and then one of you is an expert in ecology, and one of you an expert in atmospheric chemistry, and then we've got Josh down here who's going to be an expert in water. You guys all get together and start developing interdisciplinary teams. And that's how you're going to solve the major social, scientific, and engineering problems of the 21st century. So now we've got a nexus between the environment, energy, food, water, and law, God forbid, and economics. So you can see that the trend is, in fact, to become interdisciplinary. So this is interesting. I gave a talk a couple of years ago to a bunch of non-water people in Salt Lake City. And I thought, how can I impress upon them how valuable water is? So I went down to Lowe's and I bought 50 pounds of sand. And I determined that sand would cost me 10 cents a glass. Now, if you drink sand, it's good for birds because they have gizzards. It's not really good for us. It doesn't really do you a lot of good. If you want to drink beach rock, that costs 37 cents a glass. Now I have some in my house that the guy before me put in, and this plain old clean gravel is 14 cents a glass. Do you know how much we pay for tap water here in South? This is from my bill. 0.02 cents per glass. Does that make sense?
No.
That's nothing. When I was standing in front, so I have a Prius, so I'm a good guy. I'm going hybrid. When I was standing in front of the gas station a couple of years ago and was pumping gas at $4.68 a gallon, I thought, you know what I actually thought? I said, holy shit. I said, how many people are driving into this? That's exactly what I said. That's absolutely true. I was looking around, I said, how many of these people realize that for that same $4.68, they can get 8 tons of water delivered to their front door? So I decided to drink the gas. I barfed. It's not very good stuff. You need water. And yet we don't value it at all. 1 gallon of gas, 2,000 gallons of water delivered to my house. I don't even have to go and pick it up. It's amazing how little we value our water. I have to look here because I never know what I'm going to say next. I could end up off in a whole other world. So yeah, so I guess the real question is, this is the other thing that keeps me awake at night, is do we as a country or a world have the political will to do what is right for the country or the world? Or are we going to continue to do business as usual And our grandkids are going to say, what in hell were you thinking? This is the challenge that I give to you guys. Think about the world. Think about doing something good for the world every day. And I tell you, it's going to be, there's going to be a change. I was on a plane one time or at a meeting, I don't remember what. But I had some old fart say, you know what, you guys, you college professors are teaching these students about climate change and all this stuff. And I said, no. I said, they're demanding it. You guys need to be the agents of change in the world. And you can do that. You're at one of the best institutions in the world, UCI. And you have some of the best faculty members in the world at UCI. And you can affect change if you want to. And it really is something that's going to be it's going to be something that's going to become more and more important.
Transcending the current regional conflicts, it is widely believed by a diversity of entities that water can be a bridge to peace in the Middle East and other parts of the world.
And I do believe that. And that happened to be, that was the third clip I've shown, that was Jane Seymour. I don't know if you know Jane Seymour. She was my guest of honor at a dinner I had down here because she's the narrator of that film. It's called The American Southwest, Are We Running Dry? And she is an absolutely wonderful person and is very much involved with water. So one of the things that I do for fun is we've developed this WIN, Water Innovation Now. And we hope to engage the K through 12 students in thinking about a world without water. Come up with neat and innovative water conservation ideas and win neat stuff. Well, so as a result of this, I've met Rob Machado. He's like #2 male surfer in the world. When he came to our wind contest, he had just come back from Indonesia drilling water wells for people in Indonesia. This is Rob Machado. Rochelle Ballard's #1 woman professional surfer in the world. Danny Way is #1 skateboarder. He jumped the Great Wall of China on a skateboard with a broken foot. The first time he did it off TV, he crashed and broke his foot. And he then did it successfully. Bob Burnquist is the #2 skateboarder. Rob Machado, Danny Way. Geoff Rowley is another skateboarder. We've got all of these people that are action sports extraordinaires saying water is cool. And I tell you, if you get a Rob Machado or a Danny Way, and they're really, really, really nice guys. I mean, they really are. Rochelle Ballard, I hung out with her at my gala where Jane Seymour was. And these people are all committed to doing the right thing environmentally. And it's really, really fun. And guess who we have signed up for our 2011 wind contest? It's a group that's doing their 50th anniversary, 50-city tour, and it's a little group known as the Beach Boys from Southern California, and they're going to be endorsing our Wind 2011 contest. So my dream now is to get up there and play my didgeridoo. I should have brought my didgeridoo. I forgot that. Damn. I want to get up there and introduce them and play my didgeridoo. Do you know what a didgeridoo is? It's an instrument that's used by the Aborigines in Australia. It's one of the oldest known instruments, and you blow into it. It's actually a tree that the termites have dug out, and you go in there. Oh, it's so much fun. I'm up to 3 minutes in circular breathing. But if I could get the Beach Boys to let me come on stage with them, wouldn't that be cool? So these are some of our sponsors. And you'll see some of these, and we're actually getting more, and we've just met with a bunch of people. So that's a lot of fun. If anybody wants to volunteer with us, we can always use judges. This is the little village of El Rai, and it's just a little bit west of Mount Kilimanjaro in Tanzania. And we were visiting there to write an MOU, Memorandum of Understanding, between the East African Partnership, and that's a group of us, and them, to help provide them with a clinic, to help provide them with water, and with sustainable food. This village, in the drought 3 years before this, had lost 70% of their cattle, 50% of the goats and 50% of the donkeys. In other words, they were really hurting. And you could see that they were very interested in trying to better themselves. This is Simon the chief. This is the head of the elders. I'm not sitting, I would have been sitting right about here because I'm taking the picture. But now, don't I look like these guys? They look a little bit more normal in this stuff than I do, don't they? But they're unbelievably, really great people. So here we were talking about water, and these are the village elders sitting on the hill, looking down at us. And all of a sudden, Simon's talking Swahili, and he turns and he says, everybody turns at me, and he says, Ali Guanani ya Kijiji Elarai. And I thought, oh my God, what did I do now? What that says is, you are the chief of the village Elarai. And when I go back to that village and can help them solve their water problems, they are going to give me my Maasai stick. See all of the, oh, you can't see very well here. You see these guys have all got sticks? They're going to give me my stick and my belt. I don't have any belt holding these clothes up. That's why I had to wear my shorts. But the belt also is for my machete, in case I run into any lions. You know, to become a Maasai warrior, you have to have killed a lion with your bare hands. I've kind of decided I'm probably not going to do that, but you never know. Crazier things have happened in my life. Okay. Thank you very much for your attention. Enjoy your time at UCI. It's probably one of the most beautiful times and wonderful times of your lives. You won't believe that the night you're studying, you're pulling an all-nighter for an exam. But being a student is a wonderful thing. And I'd be happy to answer any questions. Thanks very much.
First, let's thank him.